Morning students. Sorry, so my laptop has some problem. Is it audible? Is it audible or not?
Yes, ma'am. Audible, ma'am.
Okay. Now, today we are going to discuss different types of graphs. So, first one is a null graph. That means null graph is a graph in which there are no edges between its vertices. That means only graph is there. A null graph is also called a empty graph. This null graph is denoted like this, n, and subscript is small n. So here the small n is nothing but number of vertices in that graph. Okay. So here tell me one thing. Whiteboard is visible.
Yes, ma'am.
It is not started. Whiteboard is not working. Okay. So now here the null graph is nothing but null graph is a graph. So in which there are no edges between its vertices. That means suppose here some graph is there like that A. Suppose some A, B, C are the graphs. Okay. In that there is no edge between A to B as well as A to C like that. There is no edges. Only vertices are there. In that case the graph is called as a null graph. And coming to the trivial graph. So trivial graph is a graph which has a one vertex. Only one vertex. In the graph only one vertex is there. Then we can call the graph as a trivial graph. So in this here, so coming to the null graph and trivial graph, difference is that null graph contains number of vertices, but there is no edge among those vertices. Whereas coming to the trivial graph is a graph contains only one vertex. To the another one, that is a simple graph. Here so here simple graph is a undirected graph with no parallel edges and no loops. That means suppose you can observe here one graph is there. So in this graph from A to B some edge is there and B to A. That means this is a undirected graph. Okay. This simple graph is a undirected graph. Here parallel edges are not edges. That means A to B only one edge is there. So another edge, there is a chance in the multi-graph multiple edges are there in the multiple edges are exist between two vertices. That is called as a multi-graph. Whereas in this simple graph there is no multiple edges between these two vertices as well as there is no loops. That means from A to A edges exist, that is called as a loop. B to B some edges exist, that is called as a loop. So there is no loops as well as there is no parallel edges. Only one edges exists between any two vertices. Then we can call that graph as a simple graph. And here a simple graph which has n vertices. So that degree, suppose a simple graph which has n vertices. So that has degree at most n minus 1. That means suppose you can observe here how many number of vertices are there here. 1, 2, 3, 4 vertices are there. So in these 4 vertices, okay, you can observe what is the degree of this A? 1, 2, 3. That means n minus 1. 4 vertices are there. In the simple graph, each and every vertex you can take at most, that means minimum 0. So that is edges instant on that vertices are minimum 0. Suppose you can leave, there is no edges from this A, even though this graph is called as a simple graph. That means there is a edge exists between B to D as well as D to C, C to B. Then also we can call it as a graph, but this is not a as well as simple graph, because there is no self loops as well as there is no multiple edges between A and B. So then we can say that this is a simple graph. And at most how many, what is the degree of each and every vertex in the simple graph. So every vertex degree in the simple graph is n minus 1. At most n minus 1. Maximum n minus 1. Minimum is 0. Maximum is n minus 1. That means suppose you can observe here, this is the figure. In this case 1, 2, 3. Suppose you can observe here the degree of this vertex is 3. Degree of this vertex is also 3. Suppose there is no edge from A to D. In that case the degree of this vertex is 2. The degree of this vertex is 2. Whereas coming to the degree of B and C are 1, 2, 3. Okay. That means at most, suppose there is no edge instant from this A. In that case is also this is called as a simple graph. So here the minimum is 0. The vertex degree is 0 and maximum degree is 3. That means n minus 1. And next another graph is a complete graph. A graph in which every pair of vertices is joined by exactly one edge is called complete graph. That means suppose if the graph contains 4 vertices, so you can pick one vertex, so that vertex that means that vertex can connected with all 3 other vertices, then we can call it as a complete graph. That means A to B edge is there, A to D edge is there, and A to C is also edge is there. So suppose you can take this C. So that means all remaining 3 vertices are adjacent to this D, adjacent to this C. Adjacent means what? There is an edge exists between 2 vertices. Then we can say that those vertices are adjacent to each other. Okay, that means complete graph in the sense, so pick any vertex, that vertex is adjacent to remaining all other vertices. That means in complete graph all the vertices degrees are same. That means you can observe here, this is the complete graph. Here the vertex of A is 3 and degree of B is 3 as well as A as well as C and D. All vertices have degree 3. So then we can say that this is called as a complete graph. Okay, a graph in which every pair of vertices is joined by exactly one edge is called complete graph. It contains all possible edges. That means you can take here all possible edges without self loops and multiple edges. So all possible edges are this. So a complete graph with n vertices contains exactly NC2. That means NC2 nothing but, suppose you can take here the n equal to 4, 4C2 nothing but 4 factorial divided by 2 factorial into 2 factorial. That means 4 into 3 into 2 factorial got and 2. That means 2 into 3, 6. How many number of edges here? 6 edges are there. Suppose you can take 5C2. So in that case how many number of edges are there? 5 factorial divided by 3 factorial into that is what? 2 factorial. That is 5 into 4 into 3 into 3 factorial got and 4. That means 2 2s are 4. Next 10 edges. Suppose you can take the 5 vertices. How many number of edges are there? That means NC2 edges. That means 5C2 edges. Means suppose you can pick one more element. So each and every element. So 5. Suppose you can take the 5 vertices. So in that case that 5 suppose every vertex degree is 4. That means how many number of vertices are there here? How many number of vertices are there? 5 vertices. That means the sum of the degrees is what? 5 into 4, that is 20. 20 divided by 2 means what? 10. That means this is undirected graph, nothing but how many number of total edges are possible, that is n into n minus 1 divided by 2. Suppose you can observe here that formula also, that is n into n minus 1 divided by 2. That means 4 into 4 minus 1, 3 divided by 2. 2 2s are 4. Okay. Means 2 into 3, 6 edges. So either you can apply the formula is NC2, otherwise you can apply the formula n into n minus 1 by 2. That means maximum edges in the complete graph. That means maximum edges in the sense total, not the maximum. You can use the term here total number of edges. That means total number of edges in the complete graph. Suppose if it is undirected graph, how many number of maximum vertices, maximum edges are there? That is n into n minus 1 divided by 2. That is the difference between maximum and term use చేసామనుకోండి, అప్పుడు n into n minus 1 divided by 2 అనాలి. బట్ ఇక్కడ కంప్లీట్ గ్రాఫ్ లో there is no maximum term. Total number of vertices, total number of edges are n into n minus 1 divided by 2. Okay, that's why this is the formula. Okay, and next one more, that is cycle graph. So coming to this cycle graph, a graph with n vertices where n greater than 3. So minimum 3 vertices. So whenever we can form any graph, you can make it any graph as a cycle graph. In that graph, minimum 3 vertices are there, and that means a graph with n vertices where n greater than or equal to 3 and n edges forming a cycle. So in that case, how many number of edges are there in the cycle graph? That means if it is the complete graph, NC2. If it is a cycle graph, how many number of vertices are there? That means minimum 3 vertices. And coming to the edges, n number of edges. That means suppose you can observe here A, B, C. That means here, what is this? This is what? Cycle. From A to C edge is there, and from C to B edge is there, and B to A edge is there. That means starting point and initial points. Initial point and end point both are same. So cycle is formed. Now this is called as a cycle graph. So in the cycle graph, whenever you can take any edge, any vertex, the degree is what? 2. Okay. Suppose you can take the cycle graph, you can take any vertex, you can take any vertex to find out the degree of that particular vertex is compulsory 2. Suppose you can take A, that is 2. Suppose you can take C, the degree of this one is also 2. Suppose you can take B, degree of this one is 2. That means in cycle graph, the degree of each and every vertex is 2 only. Suppose if the graph contains 4 vertices, so how many number of edges are there? Again 4 edges are there. Suppose if the graph contains 6 vertices, how many number of edges are there? 1, 2, 3, 4, 5, 6 vertices are there. Suppose you can, whereas coming to the trees, if tree contain n number of nodes, how many number of edges are there? Maximum how many number of edges are there? N minus 1 edges. N minus 1 edges are there. That means if it is a cycle graph, that's why this contains n number of vertices and n number of edges. So because of this reason only, a graph is a tree is a acyclic graph. That means acyclic graph with n number of nodes, it contains maximum n minus 1 edges. Okay. If the tree contains n nodes, maximum it contains n minus, that is a binary tree, n minus 1 nodes. There is no cycle is formed. Okay, and how it is displayed, denoted, that means Cn. Here n is nothing but number of vertices. A cycle graph which has n vertices, automatically it has n number of edges. So a graph containing at least one cycle is called cycle graph. Suppose from here to here also graph is some cycle is there. A to C, C to D, and this is also cycle. So some cycle is there. Okay, minimum ఒక cycle అనేది ఖచ్చితంగా ఉండాలి. Next coming acyclic graph. Here a acyclic graph, a graph does not contain a cycles is called acyclic graph. Suppose here you can remove this graph, this edge, then we can call this a acyclic graph. Okay, coming to the bipartite graph. What is a bipartite? So the name itself contains bipartite. Bipartite means two partitions. That means in the graph number of vertices are there. Those vertices are partitioned into two parts. So in the from one part to other, each and every vertex, that means there is an edge exists, one vertex in one part with all other vertices in the other part. So this is called as a bipartite graph. Suppose you can observe here, this graph contains 4 vertices. So you can pick one vertex. This vertex adjacent with all other vertices in the another set. So this is one set and this is one set. There is no edge with same set. There is no edge exist within the same set. Edges exist with another set of vertices. Okay, so that is called as a bipartite graph. Suppose you can observe here 5 vertices are there. So in these 5 vertices, so there is no edge from these in the same set. So edges exist with other set of vertices. So from this, here edge is there. So from here to here edge is there. From here to here edge is there. From here to here edge is there. From here to here edge, and from here to here edge. Okay. So here suppose you can remove this edge. From here to here some edge is removed here. So in this situation also this is called as a bipartite graph. That means there is an edge exists with other set but not in the same set. Then we can call it as a bipartite graph. That means, see here definition for this. A bipartite graph is a graph in which the vertex set can be partitioned into 2 sets such that edges only go between sets, not within them. That means edges only go between sets, not within them. Okay, a graph G equal to V comma E is called bipartite graph. Here its vertices V of G can be decomposed into or divided into 2 non-empty disjoint subsets. Non-empty disjoint subsets means each and every vertex set is non-empty. So some vertices are there in V1, some vertices are there in V2. Okay, and disjoint subsets nothing but there is no common element between these 2 vertices sets. In the V1 and V2 there is no common element. Then we can say that those 2 subsets are disjoint subset. That means the intersection of 2 disjoint subset is null. Okay, that property manaki satisfy avali. That means there is no common element between these 2. Then we can say that these 2 sets are disjoint sets. Okay, so in such a way that E belongs to E of G, that means edge set, has its one joint in V of G and other point in V of 2. That means how to form the edges. That means edges formed from one set to other set but not within the same set. So this is called as bipartite graph. Here the partition V equal to V1 union V2 is known as bipartite of G. Okay, now it is denoted like by using the symbol K, letter K, M comma N. That means number of vertices in one set and number of vertices in another set. Next coming to complete bipartite graph. So same as complete graph, here complete bipartite graph is there. So in the complete graph in the sense, so every vertex you can take in the graph that is adjacent to remaining all the vertices in the graph, then we can say that that graph is the complete graph. Okay, whereas coming to the bipartite graph, suppose you can take one vertex in one set, so that vertex is adjacent to all other vertices in another set of vertices. Okay, that means now from here to here edge is formed, from here to here edge is formed. Suppose there is no edge from here to here, this is not called as a complete bipartite graph. When we say that this is a complete bipartite graph means you can that means one vertex is adjacent to all other vertices in another set of vertices, then we can call it as a bipartite graph. That means each and every vertex in one set can adjacent to other set of vertices, then we can call it as a complete bipartite graph. That means suppose in this set 3 vertices are there, here 2 vertices are there. That's why it is represented K3 comma 2. That means here from this vertex to this vertex some edge is formed. From here to here edge is formed. From here to here edge and here to here edge. Next from here to here edge is formed. From here to here edge is formed. Suppose you can take here, this is what the 4 comma 4. So here 4, he is used only 3. 4 comma 4. Now from here to here, here and from here. This is also written down. The graph wrong draw chesamma. So this is not a complete bipartite graph. Here it is a graph 4 comma 3. So this is not a complete bipartite graph. Okay. And coming to here, another graph, that is a star graph. So it is a complete bipartite graph in which n vertices have degree 1 and a single vertex have degree n minus 1. So star graph is also bipartite graph. So one vertex set contains only one vertex and remaining all other vertices in other set. Okay. Then that means it is a complete bipartite graph in which n vertices have degree 1 and a single vertex has degree n minus 1. Suppose you can take here, this is a vertex have degree 1 and this is vertex degree 1. So this is vertex degree 1. So this is vertex degree 1. So this vertex degree is 1. So this vertex degree is 1 and this vertex degree is 1. This is also 1. Suppose you can observe here, this vertex degree is what? 1, 2, 3, 4. That means n minus 1. The degree of this vertex is what? N minus 1. Because here 4, nothing but 4. N minus 1, nothing but 4. So here how many number of vertices are there in this graph? 5 vertices. That means one vertex degree is n minus 1. So remaining all the vertices degree is only 1. So then we can say that this is a star graph. That means, so now we can put this one vertex in one set and remaining all other vertices in the other set of vertices, other set. Okay. So that this is called as a complete bipartite graph. That means from here to here edge is there, from here to here edge, from here to here edge and from here to here. So this only one vertex is in one set and remaining 4 vertices are there in another set. So that this is also called as complete bipartite graph. Star graph is also complete bipartite graph. When we say that that is a star graph means except one vertex have degree n minus 1, remaining all the vertices have degrees only 1. So then we can say that this is a star graph. Okay. So why? Because this is called as a star. This looks like a star. So that's why this is called as a star graph. So where n minus vertices are connected to a single central vertex. So how this star graph is represented as n. Here n is nothing but n number of vertices. And coming to the multi-graph, a graph in which there are multiple edges. A graph in which there are multiple edges between any pair of vertices or there are edges from a vertex to itself is called a multi-graph. That means vertex to itself. Suppose if the graph exists any self loops as well as multiple edges exist between two vertices, then we can call it as a multi-graph. So this is called as a multi-graph. So from A to C 3 edges are there. From C to D 2 edges are there. That means multiple edges exist between any pair of vertices along with that means addition of that there is an edge exists itself also is called as multi-graph. And coming to the planar graph, so this is what the planar graph. So this is called as a planar graph. That means here you can observe this is a planar graph, this is a planar graph, this is a planar graph. Okay. So this is the non-planar graph. Okay. What is a planar graph? A planar graph is a graph that can be drawn in a plane in such a way that no two edges cross each other. No two edges are cross each other except a vertex to which they are incident. Okay? There is no crossovers. Suppose you can observe here A to B, on this edge there is no edge crossover from this edge. From here B to D there is no edge cross from this, and here there is no edge cross from this. So here there is no edge cross from this. Suppose you can take the edge from A to D. So there is one edge crossover from A to D. That means C to D one edge is there, as well as A to D one edge is there. So this is some crossover is there. Now we can call this as non-planar graph. How we can convert this into planar graph? So this can convert it into planar graph by, so here A to B, B to D, D, C, C to A, and C to B is also there. Only one edge is left over. So now there is a chance from here to here also, A to D also we can form the edge. So now this is called as a planar graph. That means there is no any edge you can pick. There is no crossovers, cross each other. Okay, then we can call this a planar graph. Now coming to here, A to B edge is there and B to C. So from B to C edge is there, as well as from C to A some edge is there. So coming to the A to D some edge is there. Okay. Then D to B is also edge is there. Then D to C is also edge is there. So this is also planar graph. Suppose this can A to B edge is there, A to C is edge is there, A to D is also edge is there. Suppose they need. Next, coming to B, B to here, B to A edge is there, and B to C edge is there, B to D edge is there. So now you can observe this one, there is no crossovers. So in this case also this is called as a planar graph. Now, so this is what the non-planar graph. So here a graph that is not a planar graph is called as a non-planar graph. That means, in other words, a graph that cannot be drawn without at least one pair of its crossing edges. That means, suppose in the previous case, this is a non-planar graph. Here, some chances is to convert this into planar graph. Sometimes there is no chance to convert that graph into planar graph. In that case, the graph is called as non-planar graph. Suppose you can observe here from A to B edge is there, B to D edge is there, C to D edge is there, and this edge. After that, A to D and A to C. Okay, enough. So there is no other edges. Some B to C, there is no edge. B to E, suppose we can form this B to C like this and B to E like this. Okay. After that, C to A is there. Suppose you can observe here C to A. This is cross. That means B to C is there. Next, B to A. Okay. Suppose you can observe here B to E. From B to E, you can take the edge here. So automatically, from D to A edge is there. So that from B to E, you can try to draw the edge from outside. So here some crossover is there. Suppose otherwise you can find out this. Observe here. A to B edge, B to D edge, and D to E edge, and this is the cycle. Okay. After that, inside A to D is there and A to E is there. Okay. In that also this is a planar graph. Now coming to B to C. Now you can take this B to C from here. Okay. From B to E here. Okay. There is no crossover. Now these two edges are there. So from E to A, suppose you can take like this. B to C like this. Okay, and C to A like this. So there is no crossover. Suppose you can observe here B to E. Suppose you can take the edge from B to E here, and in the previous case we can take the edge. That edge is what? From this B to E here to here. Suppose you can take this edge. Okay, what is that edge? This edge D to C. Okay, D to C. Now the D to C is like this. Okay, B to E like this. So here some crossover is there. So means one crossover compulsory exists in this case. So that this is not a planar graph, or simply say that this is a non-planar graph. That means whenever we are trying to convert this non-planar into planar graph, there is no chance that can convert it into planar graph. In that case, that graph is called as non-planar graph. So these are the different graphs. So as already we have discussed about this spanning trees. So this is the algorithms also we have discussed, Prim's algorithms and Pushkal's algorithms. Okay, this and difference also we have discussed. So this is a planar graph. So the questions are like this in the planar graph. Okay, this is the planar graph. Here in this planar graph, how many number of regions are there? That means if vertices are 1, 2, 3, 4 vertices are there, automatically how many number of regions are there? 4 regions are there. In that 4 regions, 2, 3 regions are the interior regions and 1 is the exterior region. Suppose if you can convert graph with 4 vertices into planar graph, then it contains number of regions. That means this is one region, A, B, C is one region, C, B, D is one region, and A, C, D is one region. So 3 are the internal regions and 1 is the external region. Okay, so this is what about planar graph, and